Okay, so our final topic, we're going to be talking about circles. There's a lot of things that we're going to cover in this one video, so be sure to pay attention to the subheadings so that you can know which part of the video is talking about what topic. So we're going to start with the basics of circles, just kind of talking about the different variables and how to solve for different things. So the first thing is that a circle is measured 360 degrees. So if you go around an entire circle, it's going to be 360 degrees. I'm going to draw a circle here. So here's my circle. So if you go around this entire circle, it's going to be 360 degrees. C is means circumference, and circumference is equal to 2 pi r. The circumference of a circle is also 360 degrees. Another way to write 360 degrees is 2 pi. But if you are solving for the circumference, it's going to be 2 pi r, where r means radius. D means diameter, r means radius, and the radius is always half of the diameter. The formula for area is pi times radius squared. Pi is equal to 3.14. And then at the bottom here, I have some conversions that we're going to do in a few. So let's say I have this circle right here. That is a radius. If you go about halfway through the circle, that is a radius. If you continue all the way across, that is a diameter. So if we're given a problem, let me erase this. Let's just erase this line. And let's say we only have the radius of the circle up to about here, and the radius is 4. If I'm going to calculate the circumference, well, first let's list everything. So we have r is 4, that's the radius. The diameter is always 2 times the radius, or the radius is always half of the diameter. So the diameter is 8. 2 times 4 is 8. Now, if we're going to find the circumference, C is equal to 2 pi r. So the circumference is 2 times 3.14 times 4. And if you put that in a calculator, let's see what we get. We have 2 times 3.14 times 4, which is going to be 25.1, if I'm rounding to one decimal, please. And I'm just going to put units. Let's solve for area. So A is equal to pi r squared. So the area is equal to 3.14 times the radius squared. 4 squared is 16, so we're just going to do 3.14 times 16, which is 50.2 units squared. So area is a two-dimensional thing, so you have to write units squared. So we just found our circumference, our diameter, radius, and area. So everything's solved for here. Let's do another example. So I'm going to erase all of this. And I'm going to do one more. Clear ink. So let me draw another circle. So here's my circle. And let's say this time I'm given the whole thing as 22. So now my diameter is 22. So if my diameter is 22, we can go ahead and write D is equal to 22. If you can guess, the radius would be 11. So remember, the radius is always half of the diameter. So if you do 22 divided by 2, we're going to get 11. Now circumference is 2 pi r. So that's going to be 2 times pi, which is pi is 3.14. So let me erase this. 2 times 3.14 times the radius, which is 11. And if I put that into my calculator, we're going to get 2 times 3.14 times 11. That is going to be 69.1 units. Now let's find our area. A is pi r squared. So my area is going to be equal to 3.14 times 11 squared. 11 squared is 121. So 3.14 times 121. And that's going to give us 379.94 units squared. And the reason why I'm using units is because I don't have a unit of measurement. So whenever you don't have a unit of measurement, you can just put unit squared. If you have inches or feet or centimeters, then you can use that. But I'm just using units because I don't know what it is. Okay, so now that we've covered the basics, let's try and solve a few problems. So right here we have a circle and it says, given the circle below, find the measure of arc SUV. So what we're going to do is we are actually going to set this equal to 360 degrees because the circumference of a circle, it measures 360 degrees. So we're going to do 3x plus 9 plus 40 plus 4x minus 3 plus 97 equals 360. Now I'm just going to combine like terms. I have a 3x and a 4x. That's going to give me 7x. And then if I add 9 plus 40 minus 3 and then plus 97, I'm going to have 143. And that's equal to 360. So now I can subtract. I can subtract 143 from both sides. And I have 7x is equal to 217. And if I divide both sides by 7, 217 divided by 7, let's see, you're going to get x is 31. So x is 31, but keep in mind, they asked us to find the measure of arc SUV. With this, you're going to go in order from S. Let me make this darker. So from S to U to V, that's this part of the circle. You wouldn't want to go the other way because if you went this way, that would be SVU, but we're looking for SUV. So SUV, so what we're going to do is we're actually going to plug in our 31. So we're going to plug in our 31 here. We already have 40 for this little bit, and we already have 97 for this part. We have 40 for this part. So we're going to plug in our x value here. So we have 3 times 31 plus 9. 3 times 31 plus 9. That's going to give us 102. So now we have 102 plus 40 plus 97. So if I add 102 plus 40 plus 97, that's going to give me 239. So SUV is 239 degrees. And that is the answer for arc SUV. Let's try another problem. So this one says, given the circle below, find the measure of arc GF. So if we want, we can just already highlight, given the circle below, find the measure of arc CF. So if we want, we could already highlight where CF is, just so we know exactly what we're looking for in the end. So CF is from here to here. That's what we're looking for. So obviously that is this, which means once we find x, we're going to plug it into 3x plus 7. So we're just going to start by solving for x. And in order to do that, we're going to add everything up and set it equal to 360 degrees. So we're going to have 3x plus 7 plus 6x minus 3 plus 120 plus 4x plus 2 is equal to 360. So now I'm going to combine all of my like terms. We're going to add all the like terms. We have 3x, we have 6x, we have 4x. 3 plus 6 is 9. Plus 4 is going to give us 13x. So we have 13x. Then we have a 7 minus 3 plus 120 plus 2. So 7 minus 3 plus 120 plus 2. That's going to give us 126. So plus 126 is equal to 360. Now we're going to subtract 126 from both sides. We're going to have 13x is equal to 234. Divide both sides by 13. This cancels, and we have x equals 18. So now we are going to plug in this 18. We're going to plug in 18 over here. So now we have 3 times 18 plus 7. 3 times 18 is 54. And 54 plus 7 is 61. So arc CF is 61 degrees. So that's how we solve these kinds of problems. Now we are going to move into something else. Let's try to practice going from radians to degrees and degrees to radians. So when we're converting from degrees to radians, we're going to use this conversion. So remember that 360 degrees is equal to 2 pi. Or you could say 180 degrees is equal to pi. And pi is measured in radians. So this is 2 pi radians. And this is pi radians. So if we want to change, let's try changing 80 degrees. So if we're going from 80 degrees into radians, we're going to do 80 degrees times, how I usually think of this is I basically use dimensional analysis. If you've taken chemistry before, you might have done dimensional analysis, or if you have to convert between any units, this is usually what you have to do. So multiply it. And then on the bottom, you're going to put degrees. So we know that 360 degrees is equal to 2 pi radians. And the unit that you want always goes on the top. And in this case, the unit we want is radians. So you can see here that the degrees will cancel, and we're going to be left with radians as our unit. So we're going to do 80 times 2 times 3.14, and that's going to be divided by 360. And that's how we're going to get our radians. So let's do 80 times 2 times 3.14. That's going to give me 502.4 divided by 360. And if I divide that by 360, then I'm going to get 1.4 radians. So that's my radians. Now, let's try and convert another one. So let's try again. So I'm going to erase all of this, and we're going to try another example. So let's do 90 degrees. So if I want to do 90 degrees and turn that into radians, I'm going to do 90 times 360 goes on the bottom, 360 degrees times, let's say 2 pi radians. Now, in this case, I'm actually going to leave my answers in terms of pi. When you are switching from degrees to radians, you don't have to necessarily multiply times 3.14. So I'm going to actually leave pi just as it is. So I'm going to have 90 times 2 times pi divided by 360. Now, in this case, 90 times 2 is 180. So we have 180 pi divided by 360. Remember, I want to leave my pi there, so I'm not going to do anything with it. Right now, I'm just going to divide 180 by 360, or I'm going to try to put it in simplest form. And if you change that into the simplest fraction, 180 over 360 is going to give you pi, because 180 If you divide both the top and the bottom by 180, you're going to get 1, and then on the bottom you're going to get 2. So this is actually equal to, this fraction itself is 1/2. So I have 1 over 2 pi. Or you can just call it pi over 2. So that's my answer. I want the answer to be in terms of pi. So I'm going to have pi over 2. Or you can say 1 pi over 2, or that's equal to 1 over 2 pi. It's the same thing. Let's do one more. So this time we're going to try and convert 30 degrees into radians. So I have 30 degrees. Remember, 360 on the bottom, and then 2 pi at the top. So we have 30 times 2 times pi over 360. 30 times 2 is 60, so we have 60 pi over 360, and I want to change this just into a fraction. 60 can go into 360. If you divide both the top and the bottom by 60, you're going to get 1 at the top and 6 at the bottom. 60 divided by 60 is 1. 360 divided by 60 is 6. So I have 1 over 6 pi, or this is equal to pi over 6 radians. Now we're going to try to convert from radians to degrees. Let's erase all of this. Actually going to use the ones that we already converted from degrees to radians. I'm going to convert it back from radians to degrees. So when we did 30 degrees, we got pi over 6 radians. So let's say you were given pi over 6 radians, and you need to convert that to degrees. So you're going to do pi over 6 times, so we have pi over 6 radians, and we're going to actually move backwards. So this time we need to have degrees at the top and radians on the bottom, because we need to cancel the radians. So we're going to have 2 pi and then 360 at the top this time. So now let's convert. So we have pi over 360. We have pi over 6 times 360 over 2 pi. If we multiply across, pi times 360, that's 360 pi. And we have 2 pi times 6. 2 times 6 is 12. So we have 12 pi. Keep in mind, these pi's cancel. Pi over pi, that cancels. And now we're just doing 360 divided by 12. And 360 divided by 12 is 30. So we know this is 30 degrees. Let's try to convert again. So let's say we have pi over 3. Let us try to convert pi over 3 radians to degrees. So pi over 3 radians. Remember, this time radians goes on the bottom. So we have 2 pi radians over 360 degrees. So we're going to do 360 times pi. We get 360 pi. And then 2 pi times 3. 2 times 3 is 6. So we have 6 pi on the bottom. Remember, pi over pi cancels. And then 360 divided by 6, we have 60 degrees. So that is pi over 3 radians. If you want, you could still use this right here as your conversion factor. So if you wanted to do pi over 3 radians times, and then have pi at the bottom, pi radians, and then 180 degrees at the top, that is still fine. These are equivalent. They're the same, because if you divide 360 by 2, you're going to get 180. If you divide 2 pi by 2, you're going to get pi. So it's actually the same thing. 180 times pi is 180 pi. 180 pi. And then 1 pi times 3. 1 times 3 is 3. So we have 3 pi at the bottom. Pi and pi cancels. And then 180 divided by 3 is still 60. So either way, you get the same thing. You can choose which one you want to use for conversion. So remember, when you are converting from degree to radian, try to leave your answers in terms of pi. Moving on, to the next thing. Now we're going to try to solve for arc length. So the formula for arc length is, let me put it up here. The formula for arc length is theta over 360 times 2 pi r. Theta is just another variable. So theta is usually a variable that's measured either in degrees or radians. You often see it when you are working with angles. We used x in the past, but it's literally the same thing. Theta is just a Greek letter. So theta over 360 times 2 pi r. Let me erase this. It's not 2 pi over r. It's actually 2 pi times r. So it's theta over 360 times 2 pi r. So remember, theta is the angle. And this formula is when theta is measured in degrees. So if theta were to be measured in radians, you'd actually use theta times the radius. But in these examples, we are using theta is measured in degrees. So this is the formula that we're going to be using. So arc length, we'll just call it AL for arc length, is equal to theta over 360 times 2 pi times the radius. So here we can see our radius is 16 feet and our theta is 240 degrees. So we're just going to plug it in. We have AL is 240 divided by 360 times 2 pi times 16. So these answers, we're just going to round to one decimal place. So I have 2 times 16. I already know that's 32. And now I have 240 divided by 360. So 240 divided by 360. And then I'm going to multiply that times 32. And then I'm going to multiply that times 3.14. So my answer is 66.99. Or I'm just going to say my answer is 67. And my unit here is feet, so I'm just going to say feet. If you don't have a unit, you can just say units. So my arc length is 67 feet. Let's try another example. So right here, let me just write the formula. Arc length is theta over 360 times 2 pi r. So AL is, my theta is 315. So I have 315 divided by 360 times 2 times 3.14 times 14 for my radius. So I'm going to put all this in the calculator. First I'm going to do 315 divided by 360. Get that decimal, multiply it times 2, multiply it times 3.14, multiply it times 14. And I have 76.9 inches. So that's my arc length. So that is arc length. The last thing we are going to do is volume of a sphere. So before we were talking about circles, we did circumference and we did radius. So circumference is a one-dimensional thing. So circumference is 2 pi r. It's one-dimensional. Area is pi r squared. As you can see by the 2, the squared, area is two-dimensional. And if you're going for volume of a sphere, volume is 4/3 pi r cubed. So volume is actually a three-dimensional thing. So this is why it's a sphere instead of just a circle. So we're going to be using this equation for volume. 4/3 pi r cubed. So the only thing you really need for volume of a sphere is the radius. If you know what the radius is, you can definitely find the volume. So let's solve this. So we have volume is 4/3 times 3.14. Our radius here is 7. So times 7 cubed. So we have V equals, I'm just going to put all this in my calculator. 7 times 7 times 7. times 3.14. So I always start with my fraction, but if you're using Google Calculator, just make sure you put parentheses around your fraction so that you don't get the wrong decimal. So I'm going to do 4/3 times 3.14 times 7 times 7 times 7. And my answer is 1,436.0. Oops. .0. So this is, and it's inches cubed. So that is the unit, is inches cubed for volume. So this is my volume. Let's do one more example. I have this sphere, and this time I am given the diameter. But remember, the radius is always half of the diameter. So this time the radius is 8. 16 divided by 2 is 8. Our volume formula is 4/3 pi r cubed. So we're going to have 4/3 times 3.14 times 8 cubed. So we're going to have 4/3 times 3.14 times 8 times 8 times 8. So I have, if I'm rounding to one decimal place, 2,143.6 inches cubed. Always include your units. And that is it, folks, for circles.